Okay. So have y'all divided it? Did it work out okay?
Yes.
Okay, so when you divide it in, what is your whole part that you should have gotten on top? Okay, 3x squared. So can I just show it to you because I already did it last period. So you should have gotten 3x squared on top. When you multiply 3x squared by 2x, you get 6x cubed. Then you multiply by the 1, you get another 3x squared. And then when you subtract, all that crosses out, you have a remainder of 4. Are we good to there? Okay, so I'm going to just skip the rewrite step. Okay, you can come take a picture of this later if you did not do it. But that first part should have not been too bad. So it was 3x squared plus, and then our remainder was 4 out of 2x plus 1 left over. Okay, now remember we talked about yesterday, if only part of the integral needs u sub, you should only do it on that part. So I would split these up. Okay, this is going to be my easy part. This is going to be my u sub part, which is actually a pretty easy u substitution as well. Okay, what is the antiderivative of 3x squared? X cubed plus. And then over here we're going to do, what's our u going to be? U is 2x plus 1, which means that du is 2 dx, which means that dx is what? Great, du over 2. So I would rewrite my integral as 4 over u du over 2. And then from there, I can take out my 4 and my 2 out to the front. What is 4 divided by 2, though? 2. So that would be x cubed plus 2 integral 1 over u du. And what is the antiderivative of 1 over u? Okay, so x cubed ln absolute value 2x plus 1 plus c. Final answer. Got it? Okay, now, does anybody remember, what did we say you should look at in the integral to know that you're probably doing long division versus u substitution? Okay, it has to be bigger on the top. So look at your 1 through, I can't number, 1 through the second number 4. Okay, which of those are you not doing long division on? Okay, not long division, not LD. Okay, now can you do long division with E? No, not long division. Okay, what about number 3? Yes, you could do long division, but that would be really stupid. Well, okay, not stupid. That would be a waste of time because can you split over an x? And that's way easier. So you want to pick the easiest way, so don't pick the harder way. So you could rewrite this, okay, as x cubed over x minus 2x squared over x plus 2x over x. And if you do it like that, you get to avoid all of the complicated part. Okay, what is x cubed over x the same as? X squared. Okay, and then x squared over x leaves me with a minus 2x. And then plus 2 dx. And then from there, you can do the integral nice and easy. You don't have to worry about any long division. Okay?
We don't have to do u sub.
You do not have to do u sub either. What would your antiderivative be at that point? Okay, so add 1, it'd be x to the 3 with a 1/3. Next term? X squared. Next term? 2x plus c. Good. Okay? Now, I want you to look at number 1. If it's not long division, can you split that one up? Okay, you could try to factor. Factoring's not going to work, but it's a good idea. Okay, but what have you been practicing? U sub. What would you pick as your u? The bottom. Okay? So go ahead and work that one out. Your u is 6x squared plus 4x. What does that make your du? 12x plus 4 dx. Which means that dx would be du over 12x plus 4. Everybody good to there? Okay, at that point, look back at your original. I have 3x plus 1 over u. And then when I go to plug this in, I'm not going to write it all the way. Think about when I put this junk on the bottom down here, okay, is it going to cross out with 3x plus 1 the way that it's written right now? You can rewrite by pulling out a what? Pull out a 4 from this, and what would be left over? 3x plus 1. Okay, so remember that little trick. If it doesn't look like it's going to simplify, then write it in a way that it will. And so now when my 3x plus 1's cross out, what coefficient am I pulling to the front? Okay, 1/4 integral 1 over u du. And the integral of 1 over u is ln. So 1/4 ln absolute value. And then I'm not going to put the u, I'm just going to go back to the x stuff. So it would be 6x squared 4x plus c. Okay? Alright, how do y'all feel about this? We're a limit? We need to do one more? Can we go on? Number 2? Sure. Okay, try number 2. Okay, and I'll give you a little bit of time to actually start it off. Yeah, but then chunk, and then what's the integral of e to the u?
What?
Y'all do number 2. And that one's not anything fancy, it's just u substitution. Bless you. Okay, so you can look up if you need to see the u substitution part. The u is going to be the exponent, which makes du just a 2x. So dx is going to be du over 2x. So this is your integral now, 5x e to the u, and then du over 2x. Now remember, it's nice when the numbers cross out or simplify, but if they don't, you're just pulling out a fraction instead of a whole number. Okay, so 5 over 2 is going to be my front number. Then what is the integral of e to the u? E to the u again. Now, e to the u plus c, and then you would rewrite and plug your x stuff back in. So it would be 5 over 2 e to the x squared plus 2 plus c. Okay? So you do have your u sub quiz tomorrow. Okay, so I've tried to give you a little bit of time to get your life together, but you're going to do great on it, okay? I will give you a partner. Huh? Long division is actually not on there since we just learned it.
It's going to be the average value.
I think it's pretty much just u substitution, integrals with endpoints, and then u sub with endpoints. So it's just those 3 things. Okay, but what we are going to do today is some inverse trig. So if you want to get out your pink sheet, this bad boy right here, we are, if you don't have yours, going to write the formulas into your notes. So if you don't know where yours is or you don't feel like getting it out, that's not the end of the world. Okay?
Does it mean that we have to do homework then tomorrow?
It would be a good idea to do the homeworks before you take a quiz, but they're not due till Friday.
I'm not here tomorrow then.
No, you're here.
No, I have to tomorrow.
Oh, you're really not here. Okay. Well, I mean, it's not due till Friday either way. But it'd be a lot harder to do a quiz if you didn't do any homework over it, right? So.
It's fun and it's with Sue, so I guess I'm free.
Oh, does Samaya go to your trip too?
Yeah, tomorrow. But not my food tomorrow.
Wait, which one?
I don't
No,
know.
she went today.
And tomorrow.
She's going both days? Rebel. She's trying to get out of class. Suba, we see you! That's what I need that for anyway. Although I don't know if it does you any good to skip class if you just have to watch it later. That sounds,
But is it
like
with
you might as well
voice?
just be there.
Wait, how come when I go back to watch your videos, there's no voice? Like, just you.
Okay, so a lot of times there is voice. It's just every now and then for some reason it records it without.
Okay, can you record it for me? Oh yeah,
Tomorrow?
Quiz.
Tomorrow is a quiz, yeah. So you won't need me to record anything. Okay, I just took this straight off of your rule sheet. Okay, so if you want to have yours out, you can, but we're going to focus on rules 18 and 19. Rule number 20, I've not ever seen on the AP test. That doesn't mean they couldn't put it on there. I've just never seen it on there, so I wouldn't worry. I'd worry about 18 and 19, and then if there's one you haven't seen before, it's probably number 20, okay? All right. We are going to work 2 integrals, and these are really easy. Even though they don't look very easy, they're actually pretty. Once we do a couple, you'll be like, oh, great. Okay. All right, so you will notice that these 2 problems look very similar. The only difference is one has numbers in it, one doesn't. So all that you need to know how to do, other than knowing the formula, which you get your cheat sheet for right now, okay, is how to use them. So if your a squared is replaced by a 49, what is your a? 7. Okay, if your u squared is an x squared, what is your u? X. And what does that make your du? What's the derivative of x? 1. Okay, anytime that this happens, if du is just 1, you do not have to rewrite your dx in terms of du, because what are they if it's a 1? They are the same, right? Du is dx, dx is du, doesn't matter. If you want to do that extra step, you can, but not really necessary. So I'm going to rewrite my integral as 1 over the square root of 49 minus u squared du. Now remember, why am I allowed to do that? Dx and du are exactly the same. Okay, and then from here, you're using your formula right here. So it would be inverse sine, write it down, inverse sine u over a. What's u?
X.
What's a?
7.
7. So it'd be x over 7 plus c. Okay? Yep, that's it. Okay, so if you have your formula, these shouldn't be too bad. Alright, let's do another one like that. Number 2. This one's going to have an actual u sub on it. So it'll be 8 over square root 25 minus 2x squared dx. Okay, now keep looking back at this formula that we wrote at the top, okay, because this is important. So if a squared is replaced by a 25, what is a? A is 5. What is u? U is 2x. Okay, what is du? What's the derivative of that? 2 dx, which means that dx is what? Du over 2. Everybody good so far? Okay, we're going to rewrite our integral. So it'll be 8 on top, square root 25 minus u squared, and then dx is now a du over 2. Now, if I had an 8 on top and I have a divide by 2 extra, what am I going to bring out to the front? Okay, so I'm going to have these guys come out to the front, and now I have a 4 integral 1 over square root 25 minus u squared du. So now we can use our rule. So try to write your rule, look at it at the top of your paper. Inverse sine u over a plus c, but with a 4 in the front still. So it would be inverse sine what? What's my little piece in here? U over a, what would it be? 2x over 5 plus c. Got it? Hard or not so bad? Do you want to do one off your homework real quick and make sure? Because I wasn't going to do a bunch of those, but I'll do one more if you need me to. Yeah, why don't y'all try? Turn your homework over to the back. And which of those look like inverse sine? Between 7 through 12. Okay, 10. Do number 10. Actually, let's do one harder than 10, because 10 is probably the easiest one. Let's do, how about 11? Okay. So I want you to find your A, your U, your du, and then your dx. Okay? And remember to think about that little formula. Hey, hi. You do something?
No, class is almost over and I just got back from my last interview.
I mean, it's like 30 minutes for me over.
What period are we in?
Fifth. But I mean, you can stay, but you could go to class and not be counted absent because it's more than half left.
Alright.
Making the right choice, Mason.
Making the right choice kills me.
Okay, what should your A be? 2. Now, this is tricky. Some of you might have gotten this wrong. What is your U if U squared is 9x squared? 3x. Do you see why?
No.
Okay, so remember, the U is squared. So if I'm going to try to go back to U, I need to square root the 9x squared to get the 3x. Does that make sense? Okay, so here's what you need to do. If you have U squared, how do you get to U? You take the square root. Now, on the other example we did, can I just show you real quick? Do you see how I put it in parentheses for you? Okay, but on this one, it's not in parentheses. So that's why you would have to actually work backwards to find your U. Okay, so from there, what's my du? 3 dx, which means that dx is what? Du over 3. Okay, here goes our rewrite. So we're going to have the integral of 1 over square root 4 minus u squared, and then du over 3. What are we pulling out to the front? 1/3. I am not going to rewrite my formula. I'm just going to go straight to this part right here. Okay, so my 1/3 is coming out to the front. What is left of this is my exact formula. So it's going to be inverse sine. And then my u over a would be what? 3x over 2 plus c. Good? You want to do one more, or you feel fine? Well, okay, y'all do number 12. Look at you getting your homework done during school even. So great. Notice that your u's not in parentheses for you. You're going to have to find it on this one. So, like on this one, your u squared was a 9x squared, so you had to square root it to get the 3x. So you'll have to do the same thing on this one. Versus like the one on your notes, I had just given you the 2x in parentheses, so that's kind of the difference. Okay, so I'm going to kind of write it up here. You can check your work if you already did it. Your A was a 2. U should have been a 2x. Du is a 2 dx, which makes dx du over 2. Okay, rewrite your integral. It would have been 5. I'm just going to bring that to the outside because I don't want to do it later. Okay, 1 over square root. That's going to be 4 minus u squared. And then if my du is over 2, I'm going to put the over 2 out there with the 5. If you did that in 2 steps, though, that's fine. Okay? Then from there, you're using your rule. 5 halves inverse sine. And then remember, it's u over a. My u is a 2x, my a is a 2. Could I change anything about that? 2 divided by 2 is 1. So you could get rid of those 2's if you want to. Okay, but you don't have to. Doesn't matter. Okay? The other rule that we're now going to practice in your notes is rule number 19. So if you have your sheet, go ahead and write it at the top. Okay, so those were both inverse sine. Now we're doing inverse tan. Okay? Rule number 19 says this. Okay, the integral of 1 over a squared plus u squared du is 1 over a inverse tan u over a plus c. Actually, let's make this a 64, since we already used 4. Okay, so ready? Pick your A. Now notice the similarities between the formulas. The other ones had square roots, this one doesn't. Also, do you notice the other one had a minus on the bottom, this one has a plus, so that's another kind of difference there. Okay, so if I'm doing this one, okay, I have my plus on the bottom, my A squared is a 64. What is my A?
Wait, is it squared?
It is currently squared, so I need to square root it to go back and find A.
8.
So A would have to be only 8. Okay? So if A squared is 64, I would square root both sides to find that A is 8. Okay, now if x squared is u squared, well then what's u? X. Then du is just 1 dx. And if those are the same, then I know nothing. I'm not going to have any extra substitutes. You can write, though, dx is du. But technically, these are the exact same thing, so there's kind of no point in writing it. Okay, so integral 1 over 64 plus u squared du. Okay, that is this exact rule that you just wrote on your paper. Okay, so what do I start with here in the front? 1 over a, what would that be for us? 1 over 8. Okay, keep reading your rule. 1 over 8, arc tan or inverse tan. Remember, those are the same. And then u over a. What's u? X over 8 plus c. Okay, got it? Alright, I made another one of those for you. Oh, wait, maybe I didn't. I only made one of those? Oh, no, I did do one more. Okay. Integral of, let's make it 3 over 25 plus 49x squared. Okay. You need to find your A, your U, your DU, and your DX. Okay, think about your formula. What is in A squared spot? 25. So if A squared is 25, square root both sides, what's A? 5. If U is 49x squared, if U squared is 49x squared, what would just U be? 7x. Are we good with that? Okay, then what's du? 7dx, which means that dx is du over 7. So far, so good? Okay, we're going to rewrite our integral. Remember, u and dx are both getting replaced. Everything else is staying the same, except where could I move my 3? To the front. So I'm going to have 3 integral 1 over 25 plus u squared. And then when I get to my du over 7, I'm going to put the du here, the over 7 there. And from there, you are using your rule that you have, rule number 19. So try to write that. You have all your pieces over here. You just need to follow that rule at the top of your notes. So leave the 3/7 in the front, and then you're doing your rule. What would 1 over a be? 1 over 5 inverse tan. And then u over a would be 7x over 5 plus c. Now, could you simplify that fraction in front and make it 3 over 35? Sure. Okay, don't have to, but you could. Alright, so now I'd like for you to look at your homework and do one from that same section. Which ones are inverse tan on your homework? From 7 through 12. 7, 8, and 9. So why don't y'all do number 8 since I didn't scribble all over it. So y'all do number 8. Okay, answer should have been 1/3 inverse tan x over 3 plus c. How'd y'all do? Got it? Okay, and then remember, the funny thing is that inverse tan has that 1 over a. Sine doesn't have it, but they're just different formulas. Okay? Alright, the last thing that we are going to talk about today is complete the square and how to use it in integration. Now, if you are thinking, oh man, I hated complete the square. Okay, it's really not that bad. You're older, you're more mature. Okay, so it is going to be easy. Okay, you're going to do great. Alright, so this is part 2 of your notes, complete the square. Do y'all remember how to complete the square or not really? Okay. Okay. So here's how complete the square works. We're not solving with it like you did in Algebra 2, but here's basically how it works. If you had x squared plus 6x plus 20. Okay, this is just basic practice to make sure that you know what complete the square is. So what do I always take out of the 6? Do you remember you only take half of it? So if this is a 6, what would half of that be? 3. So you would do x plus 3 squared. Now, here's the problem with x plus 3 squared. When I square the first term, what do I get? X times x is x squared. Then think about if I wrote this twice, okay, because I don't think, did y'all learn the double formula or not really? Okay, if you did, great. You already know the middle terms is 6x. But if not, think about, you would have had an x squared. Then you would have had a 3x and then another 3x. What's that? 6x. And then what is 3 times 3? 9. So you have to think about, okay, I'm going to borrow 9 from that 20. How many will be left over? 11. So you're basically going to take whatever this is squared away from the 20, and whatever's left over just has to sit by itself. Okay? So let's do another one like that, okay, and see how it goes. So let's say that you have this. X squared plus 10x plus 45. Okay, you can only take half of the 10. How much are we taking? X plus 5 squared. What is, cover this with your finger, what's 5 squared? Then I need to borrow 25 from 45. How many get left out of the perfect square? 20. Make sense? Because this has a built-in 25. So I'm stealing that from the 45. The extra 20 stay on their own. Okay, we're going to do one more before we start doing it with complete the square in the integral. So let's say you have this. X minus 8, x squared minus 8x plus 30. You can only take half. So if there's 8 in the middle, how many can we take? Okay, x minus 4 squared. But what's 4 squared? 16. So how many of the 30 have to be off by themselves? 14. Okay, do y'all need to try one on your own, or are you good? Good? Okay. Here's how it works. We're only going to do 3 of these. They're pretty easy. Okay.
Wait,
Huh? Well, y'all in Algebra 2 did like kind of a longer solving process, but complete the square is just that step.
how do we know if we need to complete this way?
You'll see. I'll show you. Okay, so set up this integral for me. 1 over x squared plus 4x plus 20 dx. Okay, we're going to complete the square on the bottom. So, think about that step we just did. I can only take half of the middle. It's a 4x. How many can I take? X plus 2. What is 2 squared? So if I'm borrowing 4 from 20, how many get left out? 16. My next step is that I'm going to reverse these terms so that they look exactly like what we just did. So I'm going to have 1 over 16 gets to come first. X plus 2 has to come second. Okay, do you see how that's now an inverse tan problem? Okay, what is my a going to be if a squared is 16? Okay, good. A is going to be 4. And then my u is going to be this junk right here, because remember, that's u squared. So my u is just going to be the x plus 2 from the middle. Are we good so far? Okay, what is du if u is x plus 2? What's the derivative of that? 1 dx, which means do I have to rewrite that dx is u? No, but you can if you want to. Okay, so let's rewrite. This would be the integral of 1 over 16 plus u squared du. And then remember, we have a formula for that. But remember, inverse tan has that 1 over a in the front, so don't forget about that. So what's my 1 over a chunk going to be? 1/4 inverse tan. U over a, what's u over a? X plus 2 over 4. Plus u. Got it? Great. Okay, can I give you another one like that? What is my other one? Okay, write it down. It's going to be x squared minus 10x 1 over x squared minus 10x plus 29. And let's actually make on top, let's make that a 4. Okay, complete the square on the bottom. So how much can I complete on the bottom? How much can I take out? Only half of 10, which would be x minus 5. What is 5 squared for me to take away? 25, but I have to take that away from 29, so how many will be left out? 4. On top, I still have my 4 and my dx. Okay, from there, I'm going to reserve these. I'm going to, what did I mean to say? Switch those around. I don't know what I was going to say. Switch them around, though. Okay, I'm going to rewrite. Wow, my brain doesn't work. Okay, so it would be 4 over 4 plus x minus 5 squared dx. And now, it's in the exact same form that I need it to be in. Now, this 4 right here, where can I move that? Yeah, I'm just going to pull that out to the front. I don't want to leave it in the integral if I don't have to. So I'm going to put my 4 in front, and then I'm going to rewrite in a second. What is my a? 2. What is my u? X minus 5. What does that make my du? 1 dx. And remember, if it's a 1 dx, they're going to be the same. You can switch it out. So it will be 1 over a squared plus u squared du, and you have a formula for that. Now, keep in mind, your 4 is going to be sitting there in the front.
Well, a squared?
Oops, I meant to still keep that a 4, sorry. I was just thinking of the formula. Okay, so it would be 4 in the front. What's my 1 over a? Did you say 1/2 over there? Yeah, 1/2. Inverse tan. And then remember, it's u over a, so my u is x minus 5 over 2. Okay. Because remember in the formula there's a 1 over A inverse tan U over A. So remember, that's on the tan formula, it's not on the sine formula. Okay? Plus C, yep. Okay, I'd like for you off your homework to do number 14. Oh wait, change that 24 to a 26 or it won't work. Oh, and then we have to change the 100 on this one to a 90. Sorry, I forgot to tell you all that. So change both of those, 90 and 26. So what's your half on the bottom there? What would I take out? X minus 5. What's 5 squared? 25. Take that away from 26. How many are left over? 1 plus. Okay, so I'm going to reverse my order there. And then from there, if this is my A and my U, what's my A? 1. What's my U? And then remember, if that's what U is, then du, if it's an X, is just a 1 dx. And remember, if it's a 1 dx, you don't have to worry about extra funny stuff. Then from there, you can take the 2 to the outside. That's 2 times the integral of 1 over 1 plus u squared du. 2 is going to stay in the front. Now, what is my 1 over a here? 1 over 1. So you can put it, you cannot put it, doesn't really matter. I'm going to put it just so you don't forget it. Okay, and then inverse tan u over a would be x minus 5 over 1. You don't have to put, but you can if you want to, plus c. Okay? Okay, the last one that we're going to do is going to be one with endpoints, but before we do that, look at the bottom 3. One of those is arctan, one of those is arcsine, one of them is complete the square. I'd like for you to just label them. Okay, 21, 22, 23. The only difference is they have endpoints. Okay, which of those 3 will be inverse sine? 22. This is going to be inverse sine. Which of those is going to be inverse tan? 20. Oops, I wrote the wrong thing. Yep, 21. And then which one is going to need to complete the square? This one. Okay? But remember, also one more question. Because we're always going back to x, do you need to change your endpoints on these? Okay, remember when we do u sub, we would change the endpoints. But if you're using the formula and going back to x, you would not change your endpoints for these. So we're going to do one example like that, and it'll help you with these down here. Okay? Last one. Maybe I lost it. I don't know where it is. Okay, we'll just do one off the homework. Let's do number 23. Great. Okay? So, number 23, this is off your homework. You can try to squeeze it on there if you want to. Actually, 22 looks harder. Do we want to do 22 instead?
Yeah.
Okay. So, it's 5/4 is your upper bound. 0 is your lower bound. And then it's 25 minus 4x squared. Okay, so pick your A and your U, just like we've done in the past. Pretend that you don't even have endpoints. What is my A going to be? Remember to square root it. 5. And then remember you have to square root here too. What's your U? 2x. What does that make your du? 2 dx, which makes dx what? Du over 2. Okay, let's rewrite our integral. So I'm going to have 1 over square root 25 minus u squared du, and then instead of putting the divide by 2 in here, do you mind if I just put a 1/2? Is that fine? Right there? Okay, so my 1/2 from here, I'm just going to put here. But it's the same thing. You can move it later. You can do it at the beginning. Okay, now from here, you're using your formula. So keep the 1/2 in the front. This is rule number 18. The square root is inverse sine u over a. So inverse sine, and then what's my u? 2x over a is 5. Now, what's different? Why would I not put a plus c here? Because I have points to plug in. You see the difference? Now, one more time, I want to repeat what I said earlier. Because we went back to x, we're going to just use the endpoints they originally gave us. If you called this a u, then you would have to change them. But I would say for trig, it's complicated enough, I would just go back to x. Okay, and then down here, we're plugging in 0. Okay, so we're plugging in right here, 5/4. So that would be the inverse sine of 2/5 times 5/4 plugged in. Okay, well, what's going to happen in there? Okay, 2 over 4, which is what? 1/2. Okay, so far so good to there? So the 5's cross out, 2 out of 4 is a half. So think about which finger on your hand, don't say it out loud. Okay, but think about which finger would give me one sine finger and then I bend the next one. So I have to, and sine's top or bottom? Bottom. So I want one finger on bottom and then I have to bend. What angle's that? Pi 6. Okay? Now on the bottom we're plugging in 0. Well, that's going to be easy. We want the inverse sine of 2/5 of 0. Well, that's just 0. Okay, look back at your hand. I want no sine fingers. I want no bottom fingers. Who do I have to fold? 0. Because if I fold this one, I don't have any bottom fingers. My sine has to be 0. Then what do I do with those values? Subtract and then divide it in half. Because remember we had that half in the front from the u sub. So it would be 1/2 of pi 6 minus 0, which is pi 12. Okay? Do y'all want us to set up number 23, or at least what we have time for? Or do y'all want to take a break? Okay, so if you don't want to set it up, you just relax over there, okay? And we'll set it up. You what? See? Great! Hey, Justin's pushing us all today to work harder. Be more like Justin. Okay, it's x squared minus 2x plus 2. How could I shortcut that? What would my complete the square step be? If it's a 2, though, I have to cut it in half. So how many can I take? I'm only going to take 1. So it'd be x minus 1 squared. But then remember, initially it was a plus 2. So if I'm borrowing 1 from that, how many's left over? Plus 1. And then remember, I'm reversing my order on that just to try to make it easier. So my a would be a what? 1. My u would be a what? And the derivative of x minus 1 conveniently is just 1 dx. So I can rewrite my integral as 1 over 1 plus u squared. And remember, that's exactly your formula. But remember, it has a 1 over a in the front. That's important. So it'd be 1 over a, which is 1 over 1, inverse tan. And then u over a, which would be x minus 1 over 1. Why not a plus c? Because you had endpoints, and so you have to use those endpoints. So you would find capital F of 2, capital F of 1. Plug in 2 for x. What am I really finding the inverse tan of? When I plug this 2 in here. 1. Okay, now don't say it out loud if you remember it. Okay, but tangent is sine over cosine. So for me to divide them to get 1, they would have had to be the same. So on your hand, which finger is going to make sine and cosine the same so that they divide to 1? Pi 4. Okay, and then on the other one, we want the inverse tan of, we're plugging in a 1 minus 1 would make that a 0. Remember, tan is sine over cosine. To make it 0, the top needs to be 0. Remember, you're not allowed to divide by 0. So if it's sine over cosine, I want sine to be 0. Which finger do I want? 0. This one. The one that no one can, well, so that some of you can bend sneakily. So it'd be pi fourths minus 0, which is pi fourths. Look, we finished it! Your homework's almost done! Great. Okay, and so your quiz, you're going to get a partner if you want to talk about who your partner should be, and go take your quiz tomorrow. What? Yeah, I do. I have the fan on. Some kid was smoking a dang e-cig in class. Yeah, and I wrote him. So my plan, I wasn't gonna write him a referral. I was gonna go get the SRO to like kind of chew him out, you know, the police officer. And then Mr. Gunner like heard me and was like, "Who is it? Bring him to me." And so he ended up getting ISS, and so now their whole class is calling me a prom wrecker. And I'm like, I was not the one who was smoking a dang e-cig, yes. And I'd already like yelled at him twice about it.
I have a question. How do you do a complete square work?
Okay, so you're only allowed to take half of this number. So if it's x plus 3, let me get a different sheet here. So here's the complete the square stuff. If you have, let me pick a different number. Let's say it's x squared minus 12x plus 50. Okay, the complete the squares, you want to break this up to be perfect. So you always take x minus 6 because that's half of this. But now think about it. If you expanded that, you'd have x minus 6 times x minus 6 again, right? So x times x pi is x squared. Then you'd have a minus 6 and a minus 6. That's where the minus 12 comes from. But then what is 6 times 6?
36.
36. So then you're basically saying if I need 36 of these, how many would be left out? 14. And then you're taking this entire chunk here and you're rewriting it like that. But this 14 kind of like gets left out in the process.
Okay.
Does that make sense?
Yeah.
Okay, here you go. You're welcome.
I got it.
No, go for it. Stay. So I've been trying to like run my fan because my room now smells like e-cig. But he's done it 3 times, and all 3 times I told him, you can't do that at school. And he's like, it's not tobacco. I'm like, it doesn't matter. You can't have it at school. And he like kept arguing. Randall, he plays baseball. With the hair? With the hair. I mean, he does have hair, but not like crazy hair. He pretty much always wears like a hat during
Is he a
school.
Rambler?
No, I don't think so.
Oh, I know who you're talking about. He's not supposed to be in this grade.
He's not?
No.
What is he supposed to be?
Graduate. He's supposed to graduate from here.
Oh, yeah, maybe. Because he never does what he's supposed to do. And so their class is like, I can't believe you wrote him a referral. No, he doesn't get to go to prom because of you.
They're probably gonna make an
He doesn't get to go to prom for his own self. I was so mad. Like I had my life